Hierarchical visualization techniques is a very large group because a hierarchical structure seems to fit people's humans' cognition better. That we tend to put things into broader category and then divided things into smaller subcategories. So hierarchical structure provides seemingly to be a more natural way for people to perceive and gather information. So I'm going to, it cannot be comprehensive. I'm going to show you a number of probably more commonly seen examples of hierarchical visualization. Earlier in our data visualization example, the invisible residence, we already see the circle tree. So where family life is visualized as a circular tree. That's one example hierarchical visualization. On everybody's computer, your file system is a hierarchical structure that you have different folders created, subfolders nested. So we're not going to talk about those, although they are everywhere. I'm going to introduce some of the some other examples. So one idea is dimensional stacking. When we have multidimensional data, it's harder to visualize. So this dimensional stacking idea is to try to depict information that involves more than two dimensions in a two-dimensional space. The idea is to partition the data. So first, at the first level, we use first two attributes. It's an art, or try and error, and some domain knowledge will help you decide which attributes should be the first and second attributes, because the order doesn't matter. It creates different visualization. Let's say we know which attributes to put at the outest layer. So we have attribute 1 here and attribute 2 here. And those attributes are best to be nominal attributes, or they could be numerical attributes that has been discretized. So you have used binning and histogram to create intervals of the values, so that every interval is presented here. And within this box, so attribute 2 and attribute 1 put together, you can see it's going to create smaller boxes. And so every of those smaller boxes is going to hold the data that has the corresponding values for attribute 1 and attribute 2, right? So let's use this little area as one example. Within this group, we can see some data are here. So data fell in this smaller area corresponds to a subset of the data observation from the original data set that has certain attributes for attribute 1 and attribute 2, right? So here we can further divide this set of observation using attribute 3 and attribute 4, okay? And so you will have data further being partitioned using new sets of attributes. And any of those boxes can be further divided using yet a new set of attributes. So this is the idea of dimensional stacking. So this representation is adequate for data with ordinal attributes or discretized numerical attributes of low cardinality. do you still recall what cardinality is? The cardinality of an attribute is the number of possible values that attribute could have. So low cardinality will make those boxes more visually easily or more intuitively to understand. But this graph obviously has limitations. It's difficult to display more than 9 dimensions. If you nested those dimensions too deep, it will add human cognition, right? When you look at a visualization, you actually have to mentally calculate all those attributes and try to understand this. It will become difficult to interpret the result. The visualization will become less intuitive. And it's important to map dimensions properly. So when to apply attribute, what attribute should be the attributes used first to partition the data, and what attribute follows, that going to affect the visualization result. This is one example using dimensional stacking. This is a very intuitive way of using dimensional stacking because the first pair of the attribute or dimensions that's used to partition data is actually the longitudinal and latitudinal coordinates. This visualization shows different mines, oil mine, distributed across the globe. So the outer x and y axis represents longitude and latitude of a certain site, and the inner ones, represent the ore grade and the depths where the mine, where the minerals are, the oils are found. So what we see here is in this graph, we can see that there's a concentrated area somewhere that have medium grade oil that's fairly deep. So in this concentrated area, and the surrounding area have the oil that's shallower. So it's fairly intuitive to map the dimensions to the semantics, so it's easier for us to understand what the picture depicting. The second hierarchical visualization we want to see is tree map. Tree map was an invention of Ben Schneiderman, and I found it very intuitive. So tree map displays hierarchical data using nested figures, usually rectangular. So what we see here is the stock market tree map. So those blue boxes represent sectors, and the smaller boxes inside those boxes are individual companies. So the size represent the weight of company. Maybe their market values. The color represent the price change. So how much the price has changed from the last trading day. You can see, this map is also interactive as following Schneiderman's mantra that the mouse over the tiles, you can see the details. And click on the tiles, you can see the current price, maybe the other information, related information about different companies. So this is tree map. In a 3D mode, we can, following the similar idea, we can create something called info cube. Here, This is a 3D semi-transparent cube that holds other smaller 3D semi-transparent cubes and have other nested things in it. You can see anything, terminology, any commercial products, things that you can fit into a hierarchical structure, you can use this kind of visualization. And other things, the third example that we're going to see is 3D cone trees. So so this is circular tree that we've seen before, and we realize circle is actually a very good way to represent trees because by definition, a hierarchical structure will have more leaf nodes than the upper nodes, right? And the circle have exactly that feature, have smaller room here and more rooms towards the outer edge of the circle. So this is a circular tree. We already see example of this in the invisible residence. And from circular tree, we can also generate circular graph, right? So the difference between the tree and the graph is in a tree, any node can only have one parent. A graph, a node can have multiple parents, right? So in graph, in undirected graph, you don't have the relation of parent and children, but when you have directed graph, you have parents. So anyway, the limitation of a 2D tree is that you can only plot this number of nodes, right? If you actually taking the central part and lift it up, you will get a cone tree that can fit a lot of more data points into it, thousands. The only drawback is 3D space is a little bit difficult to navigate, and you typically need rotation to actually see all the data. Similarly, cone graph can be created when you have a defined center point. So this cone tree has been used in different applications. Anything, again, have a hierarchical structure. So this is the medical subject heading. So this medical subject heading as a thesaurus holds, I don't know, 100,000 terms. And those terms obviously organized in broader, narrower term categories, so therefore form a hierarchical structure. When you perform an information retrieval task in order to find, for example, articles published on COVID, you can follow this structure and find the right category for COVID, for example, coronavirus. Diseases caused by coronavirus, and that helps you to search for documents. A file system, anything that's hierarchical can be represented using 3D cone trees. The user evaluation of 3D cone trees is mixed. The basic complaint is about the 3D. It's a little bit challenging to navigate in some cases. The last hierarchical visualization that I want to show you is the one zoom. This is a great education tool. I mean, if you have children or younger siblings, it will be great to have to have them look at this. You can click on the link and get into the website. This one zoom shows the entire tree of life and how species evolves over time. Okay, so here the branches indicates the year from the very beginning to more recent days. Let me see if I can fit one part of that visualization into my recording window. Hmm. I'm going to make a separate video to show this because it's really cool. Um, using a larger recording window. Okay. Um, okay, I'll add a special link here just for one Zoom. But then we can move on to the last category of visualizations that we could use. We can call them ad hoc or miscellaneous. Other techniques that can visualize complex data and relations, notably graph. Graph is a very powerful tool that we have seen a little bit earlier here. So you have nodes and connections. There's no limitation. Any nodes can be connected to any nodes. Typically, the nodes would represent some entity, and the link going to represent certain relations. And you can use different colors, different width for the link to indicate different kind of relations. In this example, this is an interesting visualization using graph where we see lots of tiny dots and lines. This is an email uh, correspondence network, where the goal of this visualization is to show that spamming email accounts, when you use this visualization, they're going to show up here at the edges. Other normal email accounts going to show appear in the closer to the center. This visualization shows that spamming email only sends email. They don't receive emails. On the other hand, a normal email you send and receive at the same time. I thought that was a very clever idea to use graph to visualize that difference. And the word cloud, very simple, but also quite effective. You can generate word cloud from a document, from discussion board, and show quickly what are the main topics that's being discussed. And here, by looking at this graph, you can see immediately the source that generates this graph is user experience design. So quite effective. There are many, many others. As I suggested, there's no way we can cover them. We only scratch the very surface, but you see there's lots of availability. And during the courses, when we study different algorithms, we often wanted to visualize the process of the learning, the result of the learning, well, some visualization that measures the goodness of the learning, and we're going to introduce additional specific visualization methods for different algorithms. So here we just have an overview. As you can see, the categories that we have reviewed, they're not mutually exclusive. Geometric projection is actually represented in many, many different other information visualization techniques. But I thought that taxonomy gave us a reasonably good way to look at a set of visualization technique. Additional tools, visualization is such an active research area for business intelligence and the visualization for business purposes. I don't know, you can easily find 10 best tools, so there are lots of tools. And I also want to mention JavaScript has a library for manipulating documents based on data. So it's basically that you can use the data to get the data presented, get the document, that's the visualization. And manipulate the underlying data that you can change the appearance of the visualization. So it's a very flexible and powerful library for creating visualization using JavaScript. that's it in chapter 2. To summarize what we have learned in chapter 2, we look at the attribute types, and in the following discussions, studying different data pre-processing method, different mining method, we will refer back to those attribute types constantly. So those are very fundamental. Please do, if you have not really, you should be, you should tell them apart in your dream. That's how familiar you need to be with the data type concept. Um, um, so we studied the basic statistic description. Those are used so common. I'm sure you probably already had experience with those. Data visualization, we just introduced some, and I think you they're bound to be more coming up, but I think visualization has to be evaluated on two fundamental criteria. One is intuitive usability of the data visualization, whether the visualization provides you intuitive way to interpret the pattern. Second is whether it can show the pattern. Some visualization shows the pattern, but it's hard to find and hard to, measurements of data similarity is fundamental, and you definitely want to be able to recite them in your dream. Hypothesis testing, you need to understand the basic idea behind it. We're going to use it from time to time, but this concept is quite simple, right? You should be able to get it. So next chapter we're going to start to really get down to the data pre-processing step, which is the second step after you get to know your data. After you have some impressions of the overall shape of the data and the key features, something that really stood out for you, and then we will need to prepare our data set for different mining tasks. So prepare the data for mining tasks is called pre-processing. So we're going to talk about those in the next chapter.